I think in Genie 3, we really tried to push it to the limit across all of the dimensions, right? So we see that we have models that are more capable in terms of the quality of their generation. We see that, like, if you look at the resolution, the duration of the interaction, how fast the next frame can be generated, you get a very significant kind of like if you multiply all of those dimensions, you get a quite I don't know, like a 100x improvement.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm joined by Shlomi Fruchter and Jack Parker-Holder, researchers at Google DeepMind, to discuss the recent release of the Genie 3 model, which is an impressive world model that we first introduced to you here on the podcast in our conversation with Ashley Edwards almost exactly a year ago. I'm super excited to dig into Genie 3. Jack and Shlomi, welcome to the podcast.
Thank you.
Thanks for having us. Excited to be here.
This is an interesting interview to try to dig into because we covered, Genie relatively recently, but I don't want to assume that people, have listened to that interview or even know about Genie at all. So we're gonna start a little bit from the beginning and dig into the project and where it comes from and why it's exciting. I'd love to have each of you just introduce yourselves before we dig in, though, and share kind of the highlights of your path to ML research and what you're most excited about, what you research, that kind of thing. Jack, why don't you get us started?
Awesome. Thanks. So, without being too much of a suck up, my path to my path was that I was working in finance just around 10 years ago, and I did a master's part time in the evenings after work, and actually was listening to your podcast quite a lot around 2017 time. I got into ML at the time research, doing actually evolutionary methods for reinforcement learning, working with some folks from Google Brain as well, because I was in New York and there was an office there. And then I decided to do a PhD where I focused on open-ended learning, um, reinforcement learning still, and then got a bit into world models. And then by the time I finished my PhD, I was increasingly convinced that the combination of these ideas would be the really powerful big thing to do. So after my PhD, I joined Google DeepMind and then worked a little bit on a project called Adaptive Agents, which was in the Xland environment. And then after that, pretty much started Genie. So I've been doing that for a few years. I'm in the open-endedness team, which encompasses some other areas too. But we've been focusing on this idea of using world models as a path to open-endedness as part of the Genie project.
Awesome. Awesome. How about you, Shlomi?
So I started actually, my first programming kind of experience was in my teen years developing game engines, actually. So 3D engines and coming more from this kind of like a world of trying to simulate effects and like lighting effects, like liquid effects, etc. So I've been working in this space for some time. And I really like this visual domain. Then I joined Google and I've been on the Google Duplex team. So what we've done in the Duplex project is basically it was pretty much very different from visual stuff because it was mostly getting stuff done over the phone. So the Duplex project was, if people remember, from Google I/O 2018. Actually, it was like people thought, okay, wow, we have
remember that
AGI.
demo. Yeah.
Yeah, it was one of the is it AGI moments, but I don't think probably not. But I think it was definitely the nice thing.
And specifically, this was the project where Google was going to call restaurants and hairdressers to make appointments on your behalf, right?
Yeah. So when we started Duplex, the goal was actually a question of, can we build already today a bot that talk over the phone with people without them feeling this is actually a machine, right? And hitting this kind of like maybe over the phone Turing test, if you want. What we found is that although having a completely general conversation over the phone was not achievable, and until very recently was when with LLMs, already then, and that was an era of RNNs, LSTMs, and definitely not transformers. And then basically we were able to develop something that was, at least for this particular task, accomplished a lot of tasks. So that was kind of like my first touch with machine learning, and it was very interesting because it was also deep, like it was very research oriented, but also had the deployment in the real world. We ended up scaling that to call hundreds of millions of calls over for overall the like 15 countries. So basically,
Oh,
it
wow.
had quite a lot of yeah. It's less people are aware of it, but because it's not like it was mostly calling businesses to update Google Maps. And I think when you so I also of course followed things that happened on the LLM, and from GPT, and internally at Google we had the Mina and Lambda and other models very early on, and then we kind of like integrated this technology into Google Duplex. But at some point, I just felt that. Um, Maybe my visual roots kind of like came into play again, and I felt like the kind of the revolution in image diffusion models was really appealing to me. I just felt like this is a huge opportunity. It's really something like it's hitting some kind of a point of maturity. Yes, since then I've been working on video models, and one incarnation of that was Game Engine, which was a bit of a side project. We were very excited, me and a few friends. Actually, one of them was on Duplex with me. Was actually the founder of Duplex, Yaniv Leviathan, and together we basically asked the question of, is it possible to simulate an existing game, but in real time, completely by a neural network, right? And then I've been also working on VO2 and VO3. But around the time of Game Engine, I started talking to Jack. I was very impressed with the Genie line of work, and we can talk more about that, of course.
One of the things that, people are most excited about in looking at Genie is this concept of, a world model. Um, Maybe, Jack, you can kind of dig into like what that means for you and how you see the world model fitting into kind of the broader, trajectory of AI models, transformer based models, like however you think about that. What all is captured in this idea of a world model for you?
Sure. Yeah, it's a great question, which is, I guess, on one level quite easy to answer, but also could be a whole book probably of different philosophies. um, so for myself, a world model, the definition has actually slightly changed recently, I think. But what I would have said until about a year ago is a world model is essentially a model from the reinforcement learning paradigm that models an MDP. So it models taking the state, an action, and it predicts the next state. And this idea has been around for a while. A world model essentially is the model in model-based reinforcement learning. It's modeling the environment, right? And so in the early 90s, I think, Jürgen Schmidt-Huber had a paper about like recurrent world models. And then also the Diner paper from Rich Dutton came out around that time as well. And that was kind of the starting point for this like direction of research, model-based reinforcement learning. And then for me, it was really the Schmidt-Huber work in 2018 that was around the time I mentioned where I was getting interested in this field in general, that really resonated. And I was looking at sort of reinforcement learning tasks, right? And um, they were at the time these Majoko tasks, like little half cheetah and these kind of ones. And then looking at the world models paper, and it was basically saying that with a few offline examples, we could actually simulate an environment, so predicting the next state sufficiently well that we could then train policies in that model and then transfer them back to a real environment. And the policy had never trained in the real environment. And obviously that's super cool. But the setting that they had was basically that you had data from the real environment. So although it was really cool that you could do this, you could also just train in the real environment and get the same result in theory, right? Um,
Since you needed to collect that data.
Exactly, yes. But you could, right? You had the ability to do it. And that was kind of the paradigm that world models were in for a few years, is that it was showing that we could do this at all for increasingly complex environments where we actually had the environment. So if we didn't want to do model-based reinforcement learning and didn't want to use world models, we could have just used like a distributed RL algorithm and probably got really good performance a different way. And there were still benefits to doing the world model approach. Maybe it was more sample efficient, but it wasn't solving something you couldn't otherwise solve, right? Um, but then, kind of going a little bit back to like Shlomi's comment about this text to image models. I mean, I think we are both excited about that at the same time from different angles, right? And for me, that was sort of saying, look, if we can do text to image this well, and I think it was what, like 4 years ago, maybe, that like Imagine came out. Um, then okay, video will happen at some point, and then after video, maybe we'll be able to get to world models, right? And we'll be able to simulate anything with large data sets, right? And so the idea was basically, can we actually take the same concept and apply it to what I would view as a world model, which is simulating an environment, and therefore we can simulate any environments, right? And so that's why we came up with this idea of foundation world models. So it was like a world model, but rather than just being for one single environment, it was any possible environment or new environments, like a foundation model. Um, and so this was kind of a hard line we stuck to, in that a foundation model is this one thing. Foundation model is one thing. It predicts the next state given actions. And that's the kind of definition that we took. But then increasingly, other kinds of models have been considered to be world models recently. So for example, video models, text to video. And at first, it didn't really fit in with how I saw world models, but actually I think it kind of does at a different level of abstraction, right? So I think now I have a slightly broader view of world model, which is models that simulate the future given the past and some form of actions, and simulate dynamics of a world, right? So it's not explicitly modeling every transition of an MDP, which is why I would have said before, but maybe just simulating the dynamics of the world in some way that you can act and intervene in it and then get counterfactual information. Um, and that enables things like planning or like learning policies and simulation.
And Shlomi, did you have the same kind of shift in the way you thought about world models?
So yeah, I'm coming more from the I think maybe simulation, or I think about more the visual. I think our what we call word models today are very visual specific, which I think is also one of the limitations of current what we call word models at the moment. But if we go back to the word models paper and that Jack mentioned, again, the definition was pretty clear, and I think it's a good definition to start from and to kind of like anchor to, because again, the term is definitely used in many ways. But I think there is also a bit of an intuition to it, and which of course can be formalized. But at least from my perspective, is like when I started seeing, I think video models, but also image models. But when you write text, right? You provide a text prompt, and then you get you see some kind of like, it feels like there is a world behind those pixels, right? I think that's the if you want, the intuitive part. Like for things to really look like a realistic image or video, then the model probably has to have some internal representation of what's going on, how the world behaves, our of physics to some extent, right? And I think that's kind of like the, maybe in layman's term, the intuition behind the world model. Like the model probably has some understanding of the world, and it's visual, and I think that's key. And but the world model doesn't have to be visual. It doesn't have to be something that generates pixels. And I think that's the broader, kind of like the broader. Yeah. So I think in some of the, again, the literature, the word model can be in some latent space. It just should be something that we can use to make decisions and predict what's going to happen next, and maybe perform planning in the or in the RL, kind of like. Um, and learn basically how to operate in a more optimal way in an environment. But again, going back to the visual domain, which is kind of like what I think happened is basically the visual domain really worked well because diffusion models just happen to work really well for images and videos and audio as well. And then this intersection between those fields kind of like became very obvious. And I think that's where we are right now, that we just have models that are capable of generating very realistic environments, and we're trying to push along this theme.
Jack, you worked on Genie 1 and 2 as well. I'd love to have you talk a little bit about kind of the trajectory of the project. Yeah, maybe for a little bit of context, what's most amazing for me about Genie 3 is I remember the conversation with Ashley, and like in my mind, I made the assumption that this world was like real time playable. And it was like, oh no, it takes like, I don't remember what the specifics was, like 20 minutes between frames in order to do this. It's not real time playable. And, now I'm looking at this thing that, in just a year is real time playable. But, talk a little bit about, what the big, both functional and research milestones have been between these iterations of the project.
Sure. Yeah. I definitely think we did try to emphasize it wasn't real time in both these previous works. The challenge was like if you're announcing a new piece of research, you're not going to say welcome to our like non real time breakthrough because why would like it's not like the best way to like you want to make it sound exciting. You don't want to just open with a limitation. But then if
Yeah,
you put
yeah,
limitation halfway down and you've got a bunch of cool videos, people don't really get that far, right? So
yeah.
we had definitely had this challenge. Um, but I will say it was slightly less than 20 minutes. I think it was more like a
Okay.
few seconds. um, but if you think about like text to image models,
I totally over rotated on the conservative side there.
I like that because it's better to set the bar a bit lower and under promise and over deliver. But I think we did the other way maybe. Um, But essentially, like text to image models, I mean, they would need to operate at like a 20th of a second, essentially, to be at the same kind of speed as Genie 3. So I think it is quite remarkable what we did achieve with that. But going back in time a little bit, so I thoroughly recommend all your listeners to listen to the Ashley Edwards version as well. Um, Essentially, Genie 1 was quite a different beast to Genie 3. It was really the first kind of proof of concept of this foundation world model idea, right? A model that could generate new worlds, right? So there'd obviously been amazing progress in world models for single domains, starting with the Mahara and Shmita work, and then things like Dreamer, Dreamer v2, Dreamer v3, that could model increasingly complex individual environments and show that you could use them for agents to learn amazing behaviors that could solve really complex tasks. And that's like really important work in one axis, right? Of just like single domain complexity. Whereas Genie 1 was basically saying, we don't care about the complexity of the environments per se. Can we train a model that can generate new environments and new worlds at all? And the challenge with that was on the data side, because unlike training from existing environments, we don't have action labeled data from your target environment if you are going to be like trying to generate new things. So we basically collected a data set of unlabeled videos that had no action labels, um, and we had this kind of neat approach where we learned latent actions. And the really nice thing about that was that it was an example of people, and I've been very fortunate with this a few times in my career, but bumping in someone who had almost a perfect skill set for the thing I was excited about doing and the things I didn't know about. So Ashley had worked on latent action learning for maybe like more than 5 years, right? She is basically one of the ones who really pioneered that direction, but in a different context. So she was working on it to learn behaviors from videos, right? So you take videos and you want to extract the actions so you can behavior clone or do imitation learning from those videos. You need to learn like unsupervised latent actions so you can do that. Whereas we had the opposite kind of setup. We were, instead of trying to learn behaviors from the videos, we tried to learn a world model from the videos. So then we could use the world model to learn policies, right? So it's kind of a different framing. Um, and there had been a paper at CVPR called Playable Environments, which did a similar thing. It was Menapas et al. And that came out as I was writing my PhD thesis. And I was thinking, like, how are we going to do these world models from internet videos? Or like, how are we going to make this possible? And then I saw that paper and I thought, well, that's at least one path. And then basically got chatting to Ashley and she was thinking, well, actually, that does make sense. We could definitely go for this approach. And it would be a really exciting way of getting the latent actions to work at larger scale than she'd previously tried before. So for Genie 1, it was kind of this quite new idea and could we do it at all? But it was limited in scope. So we trained actually two models, which people don't really notice as well. So we trained one model on this 2D platformer game data set, and we trained another model on the robotics data set from, I think, the RT1 paper, which was this like everyday robotics arm. And in both cases, you could unsupervised learn an action space. That meant that you could give the model a new image that wasn't in the training data. Maybe it was generated by a text to image model. Maybe it was something, it's a photograph you took yourself. And then you could, from that point, play it like a world using the latent actions. Now, that sounds amazing, but there were some caveats. So it was 90p, so it was very small. And it lasted maybe a couple of seconds before it degraded. And then also, it didn't really generate anything new when you went off screen, right? So we used this like mask git approach, and it tended to have like mode collapse when you moved away. So if you look in the platformer examples, when you move to the right, it just kind of continued a flat platform rather than generating like exciting new content. So people did actually notice that, but we were definitely aware of it. It was more just like, this is kind of cool that this remotely works. And it was a very early stage project, right? Like essentially when we started this, no one really thought it was worth doing. And lucky we were in a place like Google DeepMind where people encourage these more exploratory projects. But it wasn't like a heavily resourced effort, right? It was kind of a few of us kind of scrapping together. So that was Genie 1. That one, we actually wrote a paper on it and we submitted it to ICML, which came out last summer. And so that's why I guess it feels very recent, because there's a cycle between finishing the work and the paper being published, right? So it feels much like a short time horizon. For Genie 2, the setting was basically Genie 1 paper came out around February, March 2024. We had the results for a while and we'd already kind of started thinking about the future plans and actually got to work on it. But then around that time, there was a lot of progress on video models in general. And sort of they had their moment like text to image had had a few years before. And so it became very clear to us that for the next phase of Genie, we could go for something a bit larger scale and it would probably work, right? Because we'd seen that video models had scaled pretty effectively. So we decided to go from 2D games to a data set to any 3D world data set. And we scaled it up to 360p. And it had the ability to generate environments, again, from image prompts that lasted maybe 10, 20 seconds before they degraded. So it again wasn't real time, but so you could play with it for a couple of minutes and wait a few seconds for each frame. And it kind of worked for 3D worlds. And so that was also at the time not completely obviously going to work. I think because it was doing this like autoregressive generation. And so it still wasn't clear that this would last like even 10, 20 seconds. So I think it was like quite an exciting result.
And did Genie 2 overcome the mode collapse issue as you?
Yeah, to an extent. So Genie 2 was a diffusion model. Um, so it had slightly different properties, but it still was only supporting image prompting. So it wasn't anywhere near as expressive as video models, right? It still required you to select an image for it that worked, which didn't always work. Uh, and it couldn't generate its own. It couldn't generate its own worlds, right? It required you to like generate an image that was in a certain kind of format where there's like a clear agent in the right location, for example, and then it would simulate from there. Whereas I think what I'm hoping we spend a lot of time talking about with Genie 3 is that it can definitely do that. So yeah, I mean, to kind of bookend this part, um, Genie 2 at the time, it was sort of a good sign of life for this general approach, but it wasn't real time. And we'd seen with Game Engine that was really impactful if you get that right. Um, and the visual quality was good, but it still wasn't using text as input, it wasn't as expressive, and it was nowhere near the visual quality of state-of-the-art video models like VO2, which came out at the same time, which was absolutely mind-blowing for all of us. So I think that's where my co-lead of Genie 3, Shlomi, came in and really had expertise. Uh, I like to borrow people's expertise, and at that point, it was pretty clear we had an expert in those areas.
Yeah, talk a little bit about the how you incorporated like these other approaches, game engine, Theo, like how is that incorporated into the Genie line of research? And let me think about this because I think Jack, you make a good point, which is like we've been talking about like this trajectory, like we've been talking about, Genie 1 and 2. We haven't really talked about, Genie 3 and like, when you pull up the demo, like what's super impressive about it. Maybe we'll let you do that as well, Shlomi, and then talk about how, these other projects you've worked on kind of, influenced the overall research.
Sure. So basically, I think in Genie Free, we really tried to push it to the limit in across all of the dimensions, right? So if you see it as like, if we see the progression that Jack just pretty much just talked about, right? So we see that we have models that are more capable in terms of the quality of their generation. We see that Genie 1 and Genie 2 are able to basically generate more and more um, like with worlds that have that are more consistent, but still to a limit, right? So we wanted to push on how long this trajectory can remain consistent. So that was one of the dimensions we wanted to improve, and of course the resolution, right? So I think all of those, like if you look at the resolution, the duration of the interaction, how fast the next frame can be generated, you get a very significant kind of like if you multiply all of those dimensions, you get a quite I don't know, like a 100x improvement. If you just think about it as raw compute, right? And I think it was very clear that this is not it's not something that's obvious that's going to work. So there is some risk to this project. Um, but we also felt that this is the time to go for it. So I think what happened basically is that after we launched VO2 and basically it was very well received. We felt like the quality really improved, and but was definitely not real time and not interactive. And then Genie 2 came out and definitely also pushed the envelope in this different direction. We just said, okay, let's try and combine those vectors of improvement and go to the next level, and that's pretty much what Genie 3 is about, trying to bring the best of all worlds, pun intended maybe.
And when you talk about this, like bringing the best of these worlds together, is there, is it bringing together ideas? Is it bringing together architectures? Is it bringing together data sets, or like some combination of all of the above?
First, I think it's all, this may be a cliche, but it's definitely about the people as well. So we had people from different teams, kind of like bringing their experience and their motivation and energy into this project. So I think that was a big thing. And in terms of there are definitely shared technical challenges, right? So basically, we generate the output is eventually pixels, and we had take the text as input, and we want to be able to generate something that feels consistent. So even if it's a video of 8 seconds, like Feoda generates, you still want to feel that it's consistent, right? If the camera moves around, things should look consistent. You need to want to get a feel that this is a really like was taken maybe in the real world, right? Um, and the same goes once it's interactive. We want to be able to generate the next frame based on the user's input, but still this consistency is really important because if we just there were some early models that were able to maybe generate the next frame, like actually game engine in a way was that like it was didn't have very long context, and the reason it worked is because it kind of learned a specific properties of this game of Doom, basically. So it kind of like remembered how the level looks like. So it wasn't really generating it as we would want, right? So I think that was actually being able to generate things from text. This is the core capability that you see from image models to video models. I think that was kind of like the main innovation and breakthrough for all of this line of research. That text became like you could start with text, and text is such a compressed representation, and it's such a strong way to learn concepts. So I think this is really it was obvious that we start from text this time. We want to describe the world, and then we just want to drop you into that, and then to let the user or agent to just go around and explore it. So that's I think those are the similarities of the projects, and this is how we, of course, the infrastructure hardware. We have a lot of, in general, the approach we take at Google DeepMind is to try and understand the core mechanics of how those models scale. So those concepts are pretty much, we could leverage them across different modalities and definitely different trade-offs of latency and memory, for example.
Do you have a favorite example from Genie 3?
I like the lizard, although it's not photorealistic. I really like the lizard that jumps, the origami lizard. I really like that it splashes a little bit of water once it hits the origami river. And of course, the paddles is if you know I think it was some of the examples were basically posted on X by team members, and I think I actually really like those that people kind of played with the model, and then there is one that you walk around and like the user is looking down to their shoes and basically sees them in a puddle, and it's very realistic. I think that's
Jack, your favorite example?
There's loads of really cool examples, I think, that show different capabilities, right? But the one that I think was the most surprising was the one is the inception sample, where essentially it takes a minute to probably explain this, but essentially we can prompt our model with videos. Um, and this is a really exciting capability because obviously, with an amazing video model like VO3, you can generate really cool videos and then actually prompt Genie 3 with the video and then continue from there, right? And that's something that's really exciting that we were playing around with. Um, but then one person in the team, Jakob, by mistake, actually didn't put the right caption. Um, and so essentially what you realized was if you don't align the caption or text prompt with the video latents, then actually the model kind of makes it work. Um, so basically what happens is if you're facing the world with the video prompt, and then you'll look away and this other kind of magical world will be there. And so what he tried was actually prompting the model with a video of people playing the model demo. So we have this video that was also posted on social media, of a couple of folks in Google DeepMind playing with the live demo, and then in an office room. And then the prompt was like a jungle with a T-Rex or whatever it was. And then during the Genie 3 generation, the screen that is showing what they were actually playing switches to this jungle, this jungle world, and so does the laptop. So Genie 3 knows that it updates both, which I think is pretty incredible. But then it also is the case that when you turn away, you see outside is actually the jungle, just as in the prompt. And when you go into the jungle and turn back around, you see the office that they're in, and you see them playing. And you kind of have to see it to believe it, but I think it's quite incredibly represents how the model kind of actually does have some understanding of things, because it understands that like when it updates the screens, it should do both, right? And then it also understands that if you're in an office and you go outside and you look back, then you should see some kind of building that they should be in. Um, and so I think that's really cool. It's definitely not what the goal of the project was to be able to do that per se, but I think sometimes when you pursue like interesting objectives, then unexpected things can arise, right? So I think that's a really nice example of one.
I think one, not necessarily a demo, but the capability that I'm very excited about. And I think it's one of the demos we have is for the whiteboard that has an apple and gene free written on it, and a tree. And I think the nice thing is that this is really demonstrate, I think, one of the capabilities of memory, right? And it's that's one, to me. This is like the basically what makes it a world model that you actually feel in a world, right? You look at the whiteboard, you look through the window, you come back, and it's there. It looks exactly the same. Everything is in place, and it just really, yeah, I'm really strong. Yeah.
Yeah. I was going to say for me, for the same reason, the painting roller one is super impressive. Like it's maybe it's the simplest world of all of the demos. You're in a room and someone's like painting the wall, but like you see the viewport pan away from the wall that has been painted with these random strokes and then pan back and the strokes are like perfect, perfect memory from what was painted, frames before for an autoregressive model to capture that so precisely
Yeah.
is super
I
impressive.
think when we saw that, like, generated by someone, it was kind of like a bit of a disbelief across some people on the team because it was just like we didn't even know the model was capable of doing something like that, right? Like it's not just that the original visual world is maintained, but actually the actions you took in it and the consequences of the actions you took are maintained as well. Um, it's also pretty cool because it shows you could use the model for sort of um, more vocational things as well. Um, I think that's quite interesting as a use case that we didn't really think of as well. So that's a really I think you have great taste in Genie 3 samples.
Yeah, let's talk a little bit about the model itself and like we mentioned, I think at a high level, challenges like consistency, latency is clearly a challenge. I think, you've talked about kind of resolution or the richness of the produced visuals. And, we've alluded to kind of the model being autoregressive in nature. We've talked a little bit about transformer and diffusion. Like, how should we think about the model architecture, the model and how you've used aspects of the modeling process to overcome these challenges?
Yeah, yeah, no worries. So, I think one of the key aspects of the model is it is basically autoregressive, which means in this context that um, the next frame is generated based on the long sequence, potentially long sequence of everything that happened before, right? So the model has to look at what happened before the particular frame, reason over this kind of like past, and decide which information is relevant to the next frame. And the key is that that has to happen very quickly. So that has to happen multiple times per second because we can never know what's the next actions from the user going to be, right? So, and I think that this is really what makes it real time interactive, not just real time, but real time interactive. So it responds to what the so I think this term is really that's kind of what led our design of the system and architecture, the interactivity while being real time. And basically, the everything boils down to to that kind of design this decision. And the interesting thing is that to get this to this very low latency, and to be able to look back into what happened that before, that's kind of like basically made us look into how we can leverage and pick the right architecture and scale that enables both very high quality model, but also leveraging the best, the best in class hardware that we have to actually build something that works. And it's not just kind of like it. We don't end up with, a theoretical system or something that might be a paper, but actually something that we hope eventually we'll be able to share with more people in the future.
To go on the same kind of direction as Shlomi, I think we had to really set ourselves as a team this goal of trying to be ambitious in all these dimensions, right? Which is something that if you don't commit to it right at the beginning, then it will be very hard to achieve all of it in one go, which is really the challenge and really the magic of the model, right? Is that it can have memory, high resolution, a diversity of worlds, and also be real time. Um, and I think in each of those dimensions, we had really amazing people in the team. From the team, obviously, you can see from the acknowledgements, it's a slightly bigger team than we obviously had before in the Genie series. I think I would consider it almost like a new model, but with inherited name. Um, and we really had like great people in all these different areas that worked really hard on each individual component, right? But also with awareness of the other parts. And I think that like it really is incredible to see the kind of things that people were able to put together. But each one was a challenge, right? So um, it wasn't the case that any one of those parts was easy to achieve.
And when you talked about the challenges, you didn't specifically mention consistency, and the blog post does specifically mention consistency as like an emergent property, suggesting that it wasn't necessarily something that you were designing towards. Is that the case?
I think one way to think of it is like we definitely that was definitely our goal, and we definitely designed it in a way that to achieve this goal. Like one of the when we listed our what we want to like the spec of the model, definitely a memory of about 1 minute was in it, right? That's kind of like was our goal. Um, but I think the key thing is that it's not an explicit, there is no explicit representation of the world. And that's, for example, there are a lot of approaches to have, you can implement, for example, a 3D engine that has a very explicit mesh and then this gets rendered and you can go anywhere you want, right? It has a lot of limitations, but also amazing applications. But if we go more into the machine learning world, then you have nerves and then Gaussian splats, and then that basically derives some representation of the geometry of the world, and based on that, you can just walk around and everything gets rendered, right? So these are all explicit representations, and we didn't want to do that. We think while they do have a lot of applications, they're also limited. It's much harder to have dynamics environments, and we kind of wanted the model to learn that on its own. And that was kind of like, if you want, that's I think one. So while we did it, aim for that, we didn't think we should build anything into the system to achieve it. I think that's what we, if we want to. I think we're good students of the bitter lesson, and we believe that, at least I believe that, many of those things can be learned from data alone. If you just kind of design the system in a way that it's set up to learn those capabilities.
Yeah, which also of course means that like every part has to be really done carefully, right? Because the model will learn what's in the data, right? So you have to have a really capable model that can do that, but you also have to train it on the right data so that it does learn the right things. And so it really has to be a lot of things coming together to get that without adding those other methods in.
So one of the big, features of the model that we've talked about is that, it's promptability. It starts with text that generates the world. There's also an example in a blog post of where you're prompting like the behavior in the world. Like, is that um is that Genie, or are we talking now about like an agent within the Genie environment? Like, is there a distinction between these two? And like, both, how do you see that today? But also, where do you see that whole agentic interaction paradigm going?
I think it's so maybe just to elaborate a bit on so what we call promptable word events. I think that's what you're referring to. So this capability is it's not directly tied to the agent. So you can think about it as God mode if you want. So you just want to change anything in the world. You want to have a sandstorm coming. You want to drop a box. You want to like we tried a bunch of stuff like dropping objects from the sky or changing anything. So you can just change anything in the world that you want.
Well, there's promptable world events, but there's also walk to the
Oh, yeah,
bread
yeah, yeah.
rack,
So I
walk to this,
maybe
which is different from like the up, down, left, right
yes.
types
So
of actions.
maybe I can I
But
maybe I
talk
can
about
just
both. You can start, continue with the world
yeah.
events and then we'll get to the other stuff.
So yeah, so we do have this promptable word events that allow to just make change in the world and inject some new information as like so that allows basically control of the world beyond just the prompt that's provided in the beginning, right? So this is more of like a
It's
temporally
like you're
local.
injecting a prompt in the middle of
Yeah,
your
yeah.
generation in time.
Yeah, and it's quite a hard like it's quite a deep capability, I think, because um it's not obvious like some there is not always the prompt makes sense, right? And I think like for example, you say okay, a door opens and you're in the middle of the desert. What door should open? And that's the model is like, I don't know. So we see that sometimes it can make things like, make weird stuff because the model is trying to, but when it makes sense, we often see that it does work and we get kind of like very nice and we have some very nice samples, and we have some like the dragon that appears out of the sky and lands in the middle of the and like the tunnel. So I think there are definitely some cases where it works really well and it's very powerful capability.
And now, if I can hit pause on that, like I can think of that as like, say the door opens in the desert. Like I can think of a model in which like you generate your next frame, your expected next frame with the desert, and then you like, use that as the input frame to generate a frame that will replace that frame in the continued generation. But I could also imagine, you know, that being like a crude way of doing something that's like more integrated into the model architecture. Like, can you talk a little bit about like how that is done?
I think what we wanted is to be able to we think about it as an event, right? So if you think about we walk around the world and things happen around us. Not necessarily they're not done by us. They're not the agent centric, right? So I think that's basically the distinction between what you mentioned about the agent in the world, acting in the world, maybe walking somewhere, which in the videos that you've mentioned, this was done by an external model, the SIMA model. We can talk about. I think it's very interesting. Maybe Jack can tell us a bit more because it's very. I think something that was also tried with Genie 2 and worked, so it's really cool. And then we built on top of that. Um, but if we go back to promptable word events, then the ability to it's not just based on a single frame, right? So it can be like that you want to see something in the world, and then you actually it doesn't happen immediately, but then you look to the left and you see, for example, a person. So we have some of these examples where you ski down the slopes, and then you look to the left and you have a person wearing a Genie free t-shirt. So I mean, it's like it can just materialize things in the world, but doesn't mean that it's like just pops in front of you. We want it to be like ideally something that's integrated in and makes sense in the world, right? Because it's easy to just drop something and it looks very artificial. We want it to actually be integrated to look real, right? So the model eventually wants to make things that look like a training data, which ultimately should be realistic.
So somehow like additional conditioning information that's integral to the next frame generation process, as opposed to we're just going to drop this thing in the middle of the view. Super interesting.
It's like you're telling the model to do it, and it's like, "I'll do it when I'm ready," kind of
Yeah.
thing. Like, it doesn't.
Let yeah.
That's not the technical term, but
Yeah.
yeah, it does it in a way that feels natural.
So Jack, talk a little bit about the SEMA agents.
Sure. Yeah. So we, as I said, going back to the history of the project, designed this to be an environment for agents. And at Google DeepMind, obviously, we have lots of projects working on agents. And the one that's really focused on 3D worlds is the SIMA agent. And so they're trying to train agents that can achieve language goals in sort of 3D simulated environments. And so they have an announcement from, I think, or a blog post from probably around February 2024, where they sort of showed a bit about how they're thinking about this. And what they're doing right now is they're training in existing games. So they've got a really capable agent that can do quite diverse things in different game worlds, but ultimately it's limited by only having access to those game worlds, right? So it can't train in any imaginable game world or in the real world because it's got just access to a finite set of environments to train in. And this is kind of the exact problem that Genie is trying to solve, right? Is to generate new environments. Um, but also, the SIMA agent was surprisingly general, right? So even though it's been trained on this set, like a smaller set of worlds, you can kind of drop it in one of the Genie environments that's never seen before, right? So you use text to create a Genie 3 environment or world to say you describe a scene that could be like a factory floor or something like that. And you could say in the background there's a forklift truck, and you generate this world, and then you say to the SIMA agent like, go to the forklift truck, right? Or you could even say to it like, go to the thing that can lift things or something like that. And then the SIMA agent kind of like from that point onwards treats the Genie generated world as if it's any other environment. It doesn't know that it's a model. It doesn't know anything. It just sees the pixels and it says, I'm going to press this key to achieve this goal. And then all Genie sees is the key press, right? It doesn't know what the sim agent's trying to do, because if it did know that, it might make it happen, right? All it knows is it wants to go forward, right? And so then it simulates the next frame. and then the sim agent sees the next frame and it says, okay, I'm going to keep going forward. And then these kind of happen in tandem, like back and forth. Um, and then critically, like if the sim agent does the wrong actions, it won't achieve the goal, right? If it does the right actions, it will achieve the goal. So then, of course, you can see that the sim agent can then learn from this experience to achieve the goal more often, right? And there may be some things it can't do yet, but it could learn to do in these worlds. So we essentially have signs of life that we have one agent interacting with another one, essentially to teach it new skills in these more embodied worlds, right? But and at a scale that hasn't really been done before. And then to kind of like close the loop on this, a really cool thing could also be integrating this with the world events, right? Because even a kind of benign environment, like walking down the street, might become much more interesting if you then injected, say, I don't know, a cat jumps out or something like that. So actually, you can teach our agents to be robust to all these different kinds of things, even in simple environments, because we have this additional lever to pull on the environment side um, to make it more interesting and challenging for the agents.
Interesting. Interesting. Um, Jack, earlier we were talking a little bit about the limitations of Genie One that, and this kind of balance in, communicating the limitations, leading with them versus, having them further down in the page. And they are further down in the page in your, Genie 3 blog post. But I'd love to have you riff a little bit about the limitations. And then, Shlomi, I'll turn it over to you to talk a little bit about, or at least start us off talking about kind of next steps and where you see the research going. And then you, Jack. So let's talk about limitations. How do you
So I think what we can't remember all of the things we listed, but the one that I think stands out for me is that we talked about simulating other agents, and we don't do this
any multi-agent interactions within the world?
exactly. Yeah, I think we mentioned that this is quite limited at this point. Ultimately, the model is predicting the next frames. It's able to get some kind of very basic simulation of other agents, like if you walk in their way, if they're walking and you stand in the way, they might stop. Or yeah, if a car's driving and you walk in front of it, it might stop. Um, but it's not the case that this is like very complex interaction, and so I think that's definitely a limitation. Um, and it's also something that you maybe is much more advanced in something like VO already, right? Um, so it's something that we don't have for sure. Um, I think there's clearly the 1 minute limitation as well. Like, it's kind of funny to say it because, like Genie 1 and 2, a minute was sort of like, would have been seen as incredible. Um, but I think it's a bit like the pace of our field is absolutely crazy, right? So, um, this is the kind of thing that will seem embarrassingly short, I'm sure, in the future. Um, so, um, right now we kind of say we have visual memory for a minute. Um, and I guess that is
An individual interaction or play of Genie can span multiple minutes. So it's just the context length essentially.
Yeah, then this is an important distinction. Like you can play for multiple minutes even, and it doesn't degrade or it becomes very blurry like previous generations of those models. But again, the memory is around 1 minute. Yes.
yeah, exactly. And then also there is, I guess, like real world physical accuracy is not perfect. So if you say like I want my exact street in London, it won't, it doesn't know my street. So I think that there's some I guess elements of that can't could be improved if you wanted to. If you in text, if you describe sort of like a very abstract world, it will almost certainly get it like on the money. If you describe a specific geographic location, you might notice that it's not what you hoped it would be in some way. So that's another one I think that is a limitation. Yeah.
Shlomi, are there anything that jumps out at you in terms of limitations or?
Yeah, I think a bit similarly to what you've asked before about the agents being able to take actions. So while currently the action space is relatively constrained, right? So while we can navigate, the agent can navigate. We have some actions like maybe jumping or like some opening doors, but relatively basic in terms of the semantics of the action that the agent is taking. So promptable world events give us control over the world, but they're not necessarily agent-centric actions. So I think this is definitely something that we hope to improve and expand in the futures. But because it's such it is a real limitation, and we think that especially for making the so it's quite challenging. But it's for anything that agent, like if we want the agent to take more complex actions, not just walk around, but actually be able to, for example, pick up things, maybe maybe do like type in some code, or maybe talk to a different agent. And there is a lot of that, and many things can happen in the world. And it's quite a challenging problem because there is no, we operate in the world as people, or as in a very physical way, right? We use our hands, we use our feet to walk. We have a kind of like an embodied kind of like a presence. And when we take away all of this and we are left with the visual, with pixels only, then it's much harder to define what actions should actually happen, right? When you open the door, for example, you go and it's not just open the door, right? You go and you grab the knob of the door, and you move it, right? Or and you pull it towards you. There's a sequence of like micro actions that are being taken place, and I think there is a challenging question of how to model this space of actions, but it's definitely a limitation, and I think an opportunity to expand capabilities.
So digging into next steps, I get the sense that you're both pretty excited about the agentic aspects of this. No surprise coming from DeepMind. But what's like most exciting to you, or most obvious to you, like or present for you in terms of like where the project goes? We could start with you, Shlomi.
So to me, the ability to be able to step into a world, right, that you created or someone else created, but then you can actually, right, perceive it, see it, interact with it. I think it's huge. It can be really applied to so many things, from entertainment, which is very obvious, right? You said like street view, interactive street view, for example. So it can be somewhat anchored in the real world, but take you somewhere else. And it actually reminds me of a startup I worked for like a long time ago, and we had like this kind of like a game placed in downtown San Francisco. Of course, we had to model the entire downtown San Francisco, and like it was a lot of. But the key idea of this startup was to actually have games happening in real world. So I think in real world locations, right? So that's like, for example, one thing you could have any interaction in some, but not a realistic one placed in a realistic location. Just one example among many. And yeah, I think there are other really interesting applications for people to maybe not necessarily entertainment. It can be like education, for example. It can be um, helping people see themselves accomplishing something they wouldn't have expected themselves to. Like there is something very strong about the seeing yourself, or maybe accomplishing something, and then it kind of makes you like it's a bit of a psychological perspective, but I think it's very powerful. And it's something that's not enough. Like there is the personalization aspect of being able to go into the environment, walk around, maybe prompt it in a way that looks very similar, maybe to your house, for example. So if you're afraid of, I don't know, doing something, afraid of spiders, maybe you can see yourself walk next to a spider at your home, and then maybe you can, like, your brain says, "Okay, I can do it." Right. So I mean, I think it's very out.
Lots of
It's like
real
the
world potential applications. And
Yeah,
so
yeah, exactly. So it doesn't have to be. My point is that we don't necessarily know how people will, or where this technology will go, and it's very early days for that. And that's why we had some trusted testers, kind of like, or academics interact with the model. Initially, we wanted to get some feedback, and we hope over time to learn more about the capabilities and how and the applications that people are excited about.
Jack, next steps for you.
Yeah. So, I mean, so many exciting ideas already mentioned. I think the one that really excites me is um, teaching agents to interact in like visually realistic, like embodied worlds with people in the world. I think that's a really missing capability for any of our current agents, is to interact in the physical world with humans as well. And I think that models like Genie 3 could enable that. And I also don't really think there's any other way to achieve that. So I think that's something really exciting, especially with the world events, right, which could enable really generating like diverse scenarios that we wouldn't be able to get the data for any other way. So I think this is still fairly early in the journey, but I think this is like a big step that really will open up a lot of use cases there.
Well, Shlomi, Jack, thank you guys so much for jumping on and updating us on Genie 3 and everything that you're working on. It's been really great to dig into it.
Awesome. Thanks so much for your time.
Yeah, thanks, Sam.
All right. Thank you both.
Cheers.